Hello, my students. In this video, we will study the applications of similarity in the circle. In each of the following figures, two similar triangles. Write the two triangles in order of their corresponding congruent angles and deduce the proportion of their corresponding sides. Here in figure 1, we have measure of angle A equals measure of angle D. The two angles are subtended to the same arc BC, and the measure of angle B here equals measure of angle C subtended to the arc AD, and also the third angle here, measure of angle AEC equals measure of angle DEB. So the two triangles ACE and DBE are similar. Why? Because the three angles in the first triangle equals the measure of the three angles in the second one. And now let us write the two triangles in order. Here we have measure of angle A equals the measure of angle D, and the measure of angle C equals the measure of angle B, and the measure of angle AEC equals the measure of angle DEB. So triangle ACE is similar to triangle DBE, and I write the proportional side. Here we have AC over DB, AC over DB equals CE over BE, equals AE, it is the third side, over DE. Okay. So we can deduce that we will take two ratios, AE over DE, and the other is CE over BE, and we can make a cross multiplication. So we deduce that AE multiply BE here equals DE multiply CE. Okay, so here we have two chords AB, and the other is DC. We can deduce that directly, that AE multiply BE, AE multiply BE equals DE multiply CE. And let us go to second. We have in this figure, in figure 2, we have two similar triangles. But first, we want to deduce the equal angles. We have angle, let us consider the two triangles ACE and triangle ACE, and the other triangle ADB. Here we have measure of angle B equals measure of angle E. Note that the figure ECBD is a cyclic quadrilateral, so the exterior angle DBA, here I write it, measure of angle DBA equals measure of angle E. And also we have measure of angle ADB equals measure of angle C. Measure of angle ADB equals measure of angle ECB. For the same reason, we have angle ADB is an exterior angle. And the third angle in the two triangles, it is the angle A here, and it is common. So the two triangles are similar, and we can write triangle ABD is similar to triangle AEC. So the corresponding sides are proportional. And I write the proportion here. So AB over AE equals BD here over EC equals AD over AC. AD over AC. And we consider the two ratios here, AD over AC and AB over AE. And we make the cross multiplication. We will find that AE multiply again AD multiply AE equals AB multiply AC. And we write this relation here. AD multiply AE equals AC multiply AB. Let us go to the figure here. AD, where is AD? Here, AD multiply the length of AE starting from A here equals AB multiply AC. Okay. What about the third figure? Figure 3 here. Let us consider the two triangles. The first one is triangle ABC, and the other triangle is ADB. Note that measure of angle ABC here equals the measure of angle D, and angle A is common angle here. This angle is common angle. So the third angle here, it is angle ACB equals the measure of angle DBA. Okay, because we have two angles here, angle B and the angle A equals the angle D plus angle A. Okay, so the third one equals the third one. You know that if we have two angles, only two angles in the first triangle equals another two angles in the second one, so you can say that the two triangles are similar. And you can write that triangle ABC is similar to triangle ADB. So the corresponding sides are proportional. Then AB over AD equals BC. We write it BC over DB equals AC over AB equals AC over AB, and we will take the two ratios here. AC over AB equals AB over AD, and we'll make a cross multiplication. Here we will find AC multiply AD equals AB multiply AB, AB multiply AB. So you can deduce that AB power 2, because AB multiply AB equals AB power 2, equals AC multiply AD. AC multiply AD. So let us go to the figure again. We have AB power 2, AB multiply AB, it is AB power 2 equals AC multiply AD. Okay, these three rules here in the two figures, we will use it to prove and to solve some questions. Okay, so here we have AE multiply BE equals CE multiply DE. Okay, and also here we have AD multiply AE equals AB multiply AC, and the third figure here we have AB power 2 equals AC multiply AD. Okay, let us go to the second page. Here we have this rule again, and we call it well-known problem. Here, if the two lines containing the two chords AB and CD here of a circle are intersecting at the point E, here or here, outside the circle or inside the circle, then EA multiply EB, here EA multiply EB equals ED, or you can say EC multiply ED. The same result here. EA multiply the second part of EA, it is EB. EA multiply EB equals EC again multiply ED. Okay, you have to memorize these two rules. Okay, let us solve some problems about this well-known problem. Here in this figure, we have AB. Here is in example 1. In the figure opposite, we have line segment AB. It is a chord here, AB, intersect CD equals E. And we have EA over EB. EA over EB equals 4 to 3. EA, again, EA over EB. Here is the ratio is 4 to 3. And EC equals 9 centimeters. Also ED equals 4 centimeters. Find the length of EB. Okay, of course, here 3 to 4, it is the ratio between BE and EA. It doesn't mean that BE equals 3 centimeters. Also, EA not equals 4 centimeters. Okay, so since EA over EB equals 3 to 4, so you can consider AE equals 3x and EB equals 4x. So since AB intersects CD equals E, you can say that EA multiply EB equals ED multiply AC, but EA equals 4x and EB equals 3x. So it is equal ED 4 multiply EC, which equal 9. So 4 multiply 4x multiply 3x, it is 12x power 2 equals 36. So x squared equals 36 over 12, which equal 3. So x equals root 3. And then EB, it is equal 3x. So it is equal 3 multiply root 3, which equal 3 root 3 centimeters. Example 2, find the value of x in each of the following figures, and lengths are measured in centimeters. In figure 1 here, we have AE equals 3 centimeters, EB equals 6 centimeters, CE equals 2 centimeters, and DE equals x centimeters. Here we have two intersect the chords intersect inside the circle at the point E. So you can write this since AB intersect ED equals E, so EA multiply EB equals EC multiply ED. Now substitute EA equals 3 multiply EB equals 6 equals EC, which equal 2 multiply ED, which equal x. So x equals 3 multiply 6 is 18. 18 divided 2 equals 9 centimeters. The other figure here, we have the same rule. You can say AB and DC are two chords intersect inside the circle at the point E. So AE, it is 2x. The length of AE equals multiply the length of BE 3x equals AC multiply ED 3 multiply 8. So we have 6x squared equals 24. So x power 2 equals 24 divide 6, which equal 4. So x equals square root of 4, which equal 2 centimeters. Square root of 4 is 2. And now go to third figure, figure C. Also, we have AE multiply BE equals CE multiply DE. AE, it is 15 minus x multiply 15 minus x multiply x equals AC, it is 9 multiply 4. So 15 multiply x, it is 15. X minus x power 2 as negative x multiply x equals x power 2 equals 9 multiply 4, it is 36. And here we have x squared minus 15x plus 36 equals 0. We want to find the value of x here in each figure. So we must factorize this polynomial here. X squared, it is x multiply x, and 36 equals negative 3 multiply negative 12. Note that the sum of negative 3 and negative 12 is negative 15. Okay, and to complete, we have here x minus 3 multiply x minus 12 equals 0. So x minus 3 equals 0. It means x equals 3, or x minus 12 equals 0. So x equals 12. So we have two values of x. X equals 3 or x equals 12. Okay, because here they ask about the value of x. Find the value of x. Of course, it is measured in centimeters. And we'll go to example 3. Here we have in the figure opposite, we have AB, ray AB intersect ray CD equals E, this point here, and AB equals 5 here. AB equals 5 centimeters, and the CD equals 9 centimeters, and DE equals 3 centimeters. Find the length of BE here, the length of BE. Now, what is the relation between the 4 parts? What is the relation between the 2 secants? We have E is the intersection point. So here we have ED multiply EC, okay, ED multiply EC equals EB multiply EA. And now we substitute. What is the length of ED? It is 3 centimeters. Multiply the length of EC. EC equals 3 plus 9. Okay, here we have EC equals 12. 12, it is 3 plus 9. Okay, equals EB. What is the length of EB? It is unknown. multiply EA. It is EB, the length of EB plus 5, and we complete. 3 multiply 12, it is 36, equals EB multiply EB, it is EB power 2 plus EB multiply 5 equals 5 EB. And now we can make an equation. EB power 2 plus 5 EB equals negative minus 36 equals 0, and you factorize it here. EB power 2, it is EB multiply EB 36. We can take 9 multiply 4 here, and the difference equals 5. So you can write 36 equals positive 9 multiply negative 4. Positive 9 multiply negative 4. And then EB plus 9 equals 0. It means EB equals negative 9, and this is refused because here the length of EB is negative, so it is refused. Or EB minus 4 equals 0. So EB equals 4 centimeters, and this is the result. Okay, and note that here if you put EB equals 4 here, 4, what you find that EB multiply EA, it is 4 multiply 9, EA equals, it's 36. Okay, also ED multiply EC equals 3 multiply 12, also it's equal 36. So we have the right solution. Next question here. Also find the value of x in each of the following figures. Lengths are measured in centimeters. So here we have in figure 1, we have EB multiply EA equals ED multiply EC. So 5 multiply 5 plus x equals 4 multiply 4 plus 8. So 25 plus 5x equals 4 multiply 12. Okay, as 4 plus 8, it's 12. So it is 4 multiply 12 equals 48. So the right hand side, 4 multiply 12, it is 48. So 5x equals 48 minus 25. It is equals 23. So x equals 23 over 5. Here 23 divide 5 equals 4.6 centimeters. Here in this part we have again AB multiply AC equals AD multiply AE. AB it is x multiply AC equals x plus 2x equals AD it is 3 multiply AE it is length equals 9. AE equals 3 plus 6 equals 9. So x power 2, or we can simplify it. X multiply 3x, here it is 3. X power 2 equals 3 multiply 9. It's 27. So x squared equals 27 multiply divide 3, it is 9. And x equals 3 units, 3 centimeters. Here in this figure we have again AB multiply AC equals AE multiply AD. AB equals x multiply AC. AC it is x plus 5 equals AE. It's 2 multiply AD. It is 2 plus 4. So x power 2 plus 5x equals 2 multiply 6. It is 12. And now we have x squared plus 5x minus 12 equals 0. So we'll go to calculator to solve this equation or using general formula. Here mod 5 3, we have the quadratic equation. The coefficient of x squared is 1 and the coefficient of x is 5. The absolute term is negative 12 here. So x1 equals negative 5 plus root 73 over 2, which equal 1.77. So x equals approximately 1.8, or x equals negative 6.777. It is refused because it is negative here. Okay. The relation between the length of the tangent, here we have a tangent EA, and the length of the two parts of the secants. Here we have the secant is EC. We have two parts here, ED and EC. Okay, what's the relation between the length of the tangent and the lengths of the two parts of ED and EC? We proved it already that EA power 2 equals ED multiply EC. And let's take this example here. In the figure opposite, we have EA is a tangent to the circle, and AC intersects the circle at D and C. Here, the ray EC intersect the circle at 2 points D and C respectively, where ED equals 4 centimeters and CD equals 5 centimeters. Find the length of EA. Now, according to this relation, we can write EA power 2 equals ED multiply the length of EC. EA power 2, consider it X. The length here, consider it equals X. So X power 2 equals ED, it is 4 multiply EC equals 9. The product equals 36. So X equals square root of 36, which equals 6 centimeters. Of course, the negative answer is refused. Here we have in each of the following figures, we have EA as a tangent to the circle. Find the numerical values of X, Y, and Z in centimeters. In the first figure here, we have EA power 2 equals EB multiply EC. EA power 2, it is X power 2 equals EB, it is 5 multiply the length of EC. 5 plus 8, it is 13. So X squared equals 65. And X equals square root of 65 centimeters. And here in the other figure, we have EA power 2 equals EB multiply EC. And the EA power 2, it is 8 power 2, it is 64 equals EB Y multiply Y plus 12. So 64 equals Y power 2 plus 12Y and Y power 2 plus 12Y minus 64 equals 0. So we factorize this part. It is Y plus 64, it is 16 multiply 4. Here we have Y. Of course, always you can use calculator. So Y plus 16 equals 0. It means Y equals negative 16. It is refused. Or Y minus 4 equals 0 implies Y equals 4 centimeters. And here to this part, we wanted to find the value of X and Z. Okay, so inside the circle we have BO multiply CO equals DO multiply OF. And we write it here. BC intersect line segment DF equals O. So DO multiply OF equals BO multiply CO. DO equals 4 multiply OF, it is 9 equals BO, it is X multiply 3. So x equals 36 divided 3, it is 12. Okay. So x equals 12 centimeters. Okay. Now the required here is to find z. Also we have EA is a tangent. So let us complete of length z. EA power 2 equals EB multiply EC. EA power 2, it is Z power 2. Okay. Equals EB, it is 5. Multiply EC. What is the length of EC? But we can substitute x equals 12 directly. So EC equals 5 plus 12 plus 3. Plus 12 plus 3. So Z power 2 equals 5 multiply 20. 5 multiply 20, it is 100. So Z equals square root of 100, which equal 10 centimeters. So we have Z equals 10 and X equals 12.